Hi there, Algebra 2, 3.6, just finishing up the chapter here. Solving systems using matrices. Objectives: to represent a system of linear equations with a matrix, to solve a system of linear equations using a matrix. A matrix is a rectangular array of numbers. A matrix element is each number in a matrix. So each one of those numbers would be an element. The whole deal down there would be a matrix. Okay, row operations are simple operations that allow you to transform a system of linear equations into an equivalent system. Switch any two rows. As you can see in the first one, they switch row 1 and they switch row 2. Okay, then you can multiply a row by a constant, so they multiplied the bottom one by 2. What you do to one thing, you have to do the whole thing. It is actually kind of working with your equations where if you multiply one thing of it, you have to multiply everything by it. It's the same exact concept. We're going to be taking equations and making them into matrices today. Add one row to another, combine any of these. So that would be like your elimination or substitution kind of thing. Okay? So those are your operations. What is the element at A23 in matrix A? The first one tells you what row to be in. You want to go back to here, rows are the ones that move back and forth, up and down are your columns. 3 is going to, the second number there, which is the 3, would tell you what column they're in. So, that being said, what would A23 be? Well, over 2, and then row 2, so we're in this row, over 3, it'd be 8. Okay, what is the element 1, 3 in matrix A? Well, row 1 over 3 should be 17. Okay? Okay, can you represent this system of equations with a matrix? Yes. So, what's going to happen here is this first one, A, we're going to make this into a matrix, which means we're really just going to kind of take away the variables. So we're going to get 2, and we're going to get 1 for this one. These are like having your rows. There's 2 equations there, so there's going to be 2 rows. Columns, there's going to be 3. So as you can see right here, I just took all the numbers from the equation and put them into the matrix. That is all you have to do if it asks you to take an equation. How can you represent the system of equation with a matrix? This is all you have to do. Now, on this other one, can we just jump to that? The one thing you have to have is I have to have x's. This is my x's. This is my y's. And this is my constant. Okay? So here, I can add my 2x's. I get 2x minus 3y. In the second one, I have a z. I don't have a z here, so I'm going to plus 0z, so I don't forget about it, equals 6. Okay? The next one, I'm going to have x minus, there's no y, so I'm going to have 0y, plus 3z equals 12. Okay, the bottom one I'm going to have to switch, so I'm going to add 5y over, which is going to be plus y. I have 0 z's equals just 1. Now I can go make a matrix. It is going to be 3 rows. So you're going to have 2, 1, 5. That's going to be all my x values. My y values are going to be -3, 0, 1. The next ones are going to be my z values, which are 0, 3, and 0. And then it's going to be my constants, which are 6, 12, and 1. There is my matrix for this last one. Okay, how can you represent the system equality with a matrix? Okay. Now, the last one we were representing systems with matrices. Now we're going to do it again. So, the first one shouldn't be too hard. So, first one, everything's lining up. -4, 3, -2, 1, 5, -5. It should be a -5. Okay, so there is my matrix there. Okay. One on the bottom, and I think this should have been an equals. Okay. Okay, the one on the bottom. Okay, the first one you got 3 of them, so you have. Oh, one other thing, you can put a line here. This probably means these are your constants, these are your variables. So here we have 4, -1, 2, 1. Okay, then I'm going to have 0, because there's no x values, 1, 5, 20. Okay, then we're going to have 2, -1, 0, and 7. Matrix line would go right here. Let's keep my constants separate. Okay. What is the linear system of equations does this matrix represent? Okay, this should not be too bad either. Okay, so it would be 5x plus 2y equals 7. My x value, my y value, my constant. My x would not be there, so you really could have y equals 9 here. Okay? B would be 2x really equals 6. And your bottom one would be 5x minus 2y equals 1. And those would be your linear system of equations that are represented by these equations. Okay. Now this is where it starts becoming kind of what we did yesterday, only trying to make your life a little easier. First, you want to create a matrix based off of this first one. So, you have 1, you have 4, you have -1. You have 2, 5, 4. There is my matrix, right? Okay, now at this point, you are going to do exactly what you had to do yesterday. We want one of them to disappear or eliminate. So I'm going to multiply the top by -2. When I do that, I'm going to get -2. I'm going to get -8. And I'm going to get +2. So I'm going to get 2, 5, 4. When I simplify, this is going to be 0, this is going to be -3, and this should be 6. Okay? Now, after that, you get that value, you're going to want to do a couple of things. Okay? You have 1, 4, 1. We're going to use that first one again because we changed that one. We are going to bring that one back in, and we're going to use this one we just came up with. Okay? Now, can I reduce this? We talked about right off the bat, you can do certain things to your equation. What can I multiply by on this to get this smaller? Well, if I multiply by a 1/3, let's even make it a -1/3, can I take or do that to every one of these? Well, it's still going to be 0. That's going to give me a +1, and that's going to give me a 6. Or it gets me a 2. So you're going to have 1, 4, 1 negative over 0, 1, -2. Okay, how do we get this eliminate? We'd have to multiply this by 4. So we're going to eliminate that by 4. Or multiply that by 4, so you're going to get 1, 4, -1. And I guess it'd have to be a -4. This is still going to be 0. That should be a +8. So now we have this matrix. We add this down. We're going to get 1, 0, 7. Okay. Now, we want to put the two matrices we found, which one of them being this one, and the other one being this one. So I'm going to do this one to the top because that's when I subtracted the original top. And this one was after I reduced it, which would be 0 and 1, -2. Okay, when we typically do this, we're trying to find out what x and y equals. This top one's going to be my x. This one's going to be my negative, or is going to be my y. These come from the constant values here. And that's how you find it using a matrix. Okay, let's try it one more time. This one, the book doesn't have, so we got to figure this out on our own. Okay, so this next one, you would have 9. You would have -2 equals 5. Okay, constant there. You're going to have 3, 7, 17. Okay, that's my matrix. I got to get this first one to disappear. I'm going to multiply by -3, so I'm going to get -9. I'm going to get, I'm going to make that up a little bit. Alright, I'm going to get -2 here because it's going to stay the same. 5, let's get that wrote down. -3 times that is going to give me -21. -3 times that is like a -51 if I recall. Gone. 23. 51. I do not believe I can reduce this. Okay, so we change the bottom one again first. Okay, so now we're going to take the top minus our new one. Okay. The only problem I'm seeing so far is this is kind of a number that you might not want to necessarily mess with because of the fact that it is you're going to have to multiply by a decimal answer. Trying to think. Aha. Here's one thing we didn't do, and this is why I'm off. This would have been negative 46, which means we could take a negative, and we could divide everything by negative 23, which would then make this a positive 1, and it would make this number a 2. We reduced it. We divided it by 23. So we divide by negative 23, divide by negative 23, divide by negative 23. We get this. Okay? Now we need to get rid of this one. So we're going to multiply everything by 2 on the bottom. We're going to get 9 minus, or negative 2, 5. And on the bottom we're going to get 2 and 4. And this is still going to be 0. We get this. You're going to get 9. You're going to get 0. You're going to get 9. Okay? So at that point, I have 0, 1, 2 is my bottom of this new matrix here. Okay, I have 9, 0, 9. Can I reduce that? Sure I can. I can take a 9 out of each one of these, right? So this becomes 1, 0, 1. Which then means my ordered pair is 1, 2. Guess we'll go this way up. It's not a matrix C anymore, or matrix. So, that would be your answer for the other one. Okay, last slide is putting this into your calculator. So, to do this, there's a couple different ways. This is the way Mr. Rita likes to do it. So he's going to do it that way. Okay. You would turn on your calculator, so you'd hit the on button. You're going to go second, matrix, which is right here. Okay, you can see that. Matrix. Okay, you're going to go over to the edit. So you're going to start over here. You're going to go over to edit. You're going to hit enter. You're going to put in that this would be a 3 by 4, which I've already done. You're going to implement all the numbers. Implement all the numbers. And then you should be done. Okay, then I'm going to go second. Quit, which is right on mode. Okay, I'm going to go second again. I'm going to go to matrix. I'm going to go to math. And I am going to go ref with the double F. And then I'm going to go second again, matrix. I'm going to hit A. And it's going to come up like this. Which I can now see everything. Now, the one thing that's happening here is it's coming into a decimal. So I'm going to go mode, because if I recall, it wants it in fractions. I'm going to hit fractions. I'm going to hit enter again. And I should get this beautiful little matrix. And this is the answers to your inequalities. So this is one way you could literally solve these and not have to do all the work. Okay. So you could do that to the second one. It's not that hard. There is your homework, 2 of which are on the scientific calculators. Okay. There is your homework.